a bit of a look at probability, and we've had a look at how we can work out probabilities as a fraction. That seems to be the most useful way of writing them. So how many outcomes work for us, how many outcomes are there altogether. We can also use decimals, and if we're pushed sometimes we might use percentages, but we'll try and use fractions and decimals wherever we can. They're much more useful for us to work with later on as well. And it ties in quite nicely because that's what we've just been doing, haven't we? Doing work on fractions just before we were looking at negative numbers, and now onto our probability. So just to get us started with today, I'd like you to have a think about these questions. We've got three different spinners A, B, and C, and they've got red, green, and in two cases they've got blue sections marked on them. All right, they're all split into different numbers of sections. So spinner A's got 4 sections, 3 of them are blue, 3 of them are green. Spinner B has got 6 sections, and spinner C has got 8 sections. What I'd like you to do is to just pause the video in a minute and to see if you can write out the fractions that it says at the bottom of the screen. So for spinner A, can you say, what is the fraction probability that we would get red? What is the fraction probability that we would get green? And then on to B, what is the fraction we'd get red? What is the probability we'd get green? The probability fraction we'd get blue, and the same for C. Okay, so just pause the video now and have a go. See if you can write out those probabilities as fractions. Once you've done those questions, start the video again and we'll have a look at how we got on. Okay, so let's have a look at how we've got on then. You can check these off with me, and I'm going to choose a pointer so I can write on here. I'm going to choose a pen. So if we want red on the first spinner, there is only one red section out of the 4. So we should have, that probability is 1/4. If we look at green, there are 1, 2, 3 green sections out of the 4 possibilities altogether. So that's 3 out of 4. If we look at B, there is 1 red section, but this time there are 6 possibilities altogether, 6 different sections we could land in. So 1 out of the 6 would give us red. If we look at green, there are 2 green sections, 6 sections we could land on altogether. And if you thought about that a little bit, hoping that a number of you will have realized you can simplify that, because these are both even numbers. How many 2's in 2? 1. How many 2's in 6? 3. And then we go on to the blue ones. The blue ones, we've got 3 blue sections, 6 sections altogether. Again, if you're ahead of me on this, 3 and 6 are both in the 3 times table. 3 goes into 3 once, and it goes into 6 twice, 1/2. Look at it. 1/2 of that spinner is blue. Yeah, 3 of the sections. Now look at spinner C. Spinner C, we've got 1, 2, 3, 4, 5 red sections. There are 8 possibilities for the section we could land in this time, though. So it's 5 out of 8. For green, we've got 2 sections, 2 out of 8. And again, we can simplify that down. They're both even. 2's into 2 goes 1. 2's into 8 goes 4. 1/4. 1/4 of that spinner is green. And then for the blues, we just have 1 section is blue out of 8. If I asked you what was the probability of getting a black section on spinner A, what do you think you might have said there? Well, black is impossible, isn't it? There is no black section on spinner A. So impossible means we have a probability of 0. 0 means it can't happen. 0 means impossible, remember. Okay, good job. Let's move on. So what we're going to have a look at today is how we can use a diagram called a sample space diagram to help us work out probabilities where more than one thing might be happening. We've got combined events happening here. And here we've got 2 spinners. Spinner A has got the numbers 1 to 3 on it. Spinner B's got the numbers 1 to 3 on it, but they're not the same spinner. They are different. Okay, spinner A is split into 6 sections. Spinner B is split into 3 sections. And if we look at spinner A, there is only 1 section that's got a 3 on it. There are 3 sections that have got a 1, and there are 2 sections that have got a 2. We're going to spin these 2 spinners and add the scores together, and then we're going to want to think about what's the probability of getting a different score. Okay, say what's the probability of getting a 4 is a question we could ask. When we spin these spinners, what's the probability that when we add the numbers together, we get a 4? So we start off with a sample space diagram, and we draw it out just like this. It's just like a table. Okay, so I'll just bring up my laser pointer. So we've got spinner A's scores here, and I've written them out in order. Okay, 1, 2, 1, 3, 1, 2. That's what's going across the top here. Look, 1, 2, 1, 3, 1, 2. Write out all the numbers that can be on spinner A. Down the side here, I'm going to write what I can get on spinner B. Well, I can just get 1, 2, 3. So I've got 1, 2, 3. I'm putting a plus here because I'm telling myself that I'm adding the scores together. So I've just got an addition grid. The scores on spinner A here, the scores on spinner B here, and now I'm just going to add up in the middle. And 3 of them are done for me. 1 add 1 is 2. 1 add 1 is 2. But here, 2 add 2 is 4. Okay, so I'm just going to fill in the rest of this and walk you through what we're doing. So here, we've got for this position, we're going to have 1 and 2 to be added together. So that is going to be a 3. So just working across the row. Coming across then, we've got 1 and 3 to be added together. That's a 4. 1 and 1, well, that's another 2. 1 and 2, that's another 3. So we see how all this is going. We've got 3 again, 3 again. We've got 5 here. We've got 3 again. We've got 4 here. We've got 4. We've got 5. So we're just going to fill them all in all the way through. 4, 6, 4, and finally at the end here we've got a 5. So we've filled in our sample space diagram. We've got the scores across from the first spinner, spinner A, across the top, the scores from spinner B down the side, and then all we've done is add them up because it said the scores are added together. Okay, this diagram here is called a sample space diagram. Okay, we've listed out our sample space in a diagram, and the sample space shows all the different possibilities. So I can see there are lots of different ways, okay, on that first row that I could make 2, lots of ways of that happening. But I can see there's only one way of making a 6. I can only get a 6 in one way if the spinner A landed here and the spinner B landed here. There's only one of those. Okay. So if we want to think about what's the probability of getting a 6, well, there's only one way it can happen. There's only one of these little squares in here that can happen. How many different outcomes are there? How many different squares are there altogether? How many different things are there here? Well, I've got 1, 2, 3, 4, 5, 6. 1, 2, 3 down. The total number of squares here, showing me the total number of outcomes, is 6 times 3. There are 18 little squares here. 18 little squares all the way across. But only one of those is what I was after, the 6. So my probability of getting a 6 is just going to be 1 out of the 18 squares. Only 1 out of the 18 squares is a 6. Okay, what's the probability of getting an odd total? Okay, this is a question that we're going to have to think about a little bit more. Well, let's come back to my diagram and let's see if we can ring the ones that are odd. Let's do that for the minute. So on that first row, there are just those 2 3s. On the second row, there's a 3 there. There's a 3 there. There's a 5. There's a 3. Coming on to the next bottom row, 5 and a 5. That's all we've got. They're all the odd ones. So how many have I got? I've got 1, 2, 3, 4, 5, 6, 7, 8. 8 out of the 18. Okay, 8 out of the 18. And if you're ahead of me, you'll be spotting that that cancels down because both of those are even. 8 out of 18. If we divide the 8 by 2, we get 4. If we divide the 18 by 2, we get 9. Just a little bit less than a half. All right, 4 9ths, not 4 8ths. That would be a half. 4 9ths, a little bit less than a half. So slightly more of the total scores are even. But we can look at that diagram, okay, and it helps us to answer some questions that we'd find quite difficult to do without having the diagram, okay? Without that sample space diagram, if I hadn't have filled in all those totals, if we hadn't done that together, it would be really difficult for you to answer that last question that we've just done. What's the probability of getting an odd total? Really, really difficult. The diagram makes it really easy. We've filled in our totals. We can look at the ones that are odd, and we can see how many different squares there were altogether. Okay, in our grid, there were 18 different ways of doing it. 8 of them were odd. So 8 out of 18. All right, let's have a look at another kind of situation that we can sometimes get. So we've got 5 counters in this bag here, and I'm saying that 2 of them are red, 2 of them are yellow, 1's blue. If I just take a counter out of this bag, what's the probability I get a yellow one? Well, there are 5 counters altogether, and 2 of them are yellow. So what do we think? Hopefully you're thinking that it should be 2/5. Okay, 5 counters in there are in there altogether, and 2 are yellow, 2/5. What if we thought about taking a counter out, looking at it, then putting it back in the bag, and taking a second counter out? And we're going to record what colours we got from those counters. Okay, so I'm going to start off with a sample space. We can see here, if I start off with a sample space, where I'm listing out what the first counter was. There were 2 reds, so I put red down twice. There were 2 yellows, I put yellow down twice. Yeah, 2 red counters, 2 yellow counters, 2 reds, 2 yellows, and a blue. But my second counter could also be red twice, yellow twice, or blue. So now I can think about how I'm going to fill this table in. I'm just going to write down the combinations. Okay, the combinations that I've got here. So I'm going to reveal that first square. That first square, I'm saying the first counter was red, and the second counter that I got was red, because it was red, and then red, red, and then red. Okay, if I do the rest of this column, we'll fill all of those ones in. So rather than doing a total like we were doing last time, we're just listing. We got red and then red. So if I look at the rest of that column, this is still red and then red. But this one here, I got red first and yellow second. So I'll write RY. This one, again, red first, yellow second, RY. And this one here, red first, blue second, RB. Okay, so hopefully you can see how all that's filled in. I've filled in what the first counter was, and then written after that what the second counter was. So here we had first a red counter, and then a yellow counter. So we write that as RY. I filled in the rest of the table. That's what the rest of it looks like, doing the same sort of thing. So down here, we take this one as an example. I had yellow first, and then blue. Okay, I've just filled in my sample space. So what's the probability of getting a yellow with your first pick and a blue with your second pick? All right, so let's bring my pen up here. So we want yellow with the first pick and blue with the second. So we're going to have a look at where that happens. Well, I can see one here. Yellow with my first pick, blue with my second. Yellow with my first pick, blue with my second. Are there any more? Yellow with the first. Well, this is the only places that yellow with the first happens, isn't it? In these 2 columns here, this one and this one. And that's the only place where I'm going to get blue second. So yellow and blue. There are just 2 ways that can happen. Okay, just 2 ways that can happen. Out of how many altogether, though? Well, again, if I look at all my outcomes in this table, what have I got? I've got 5 across in a row and 5 down in a column. If I do 5 times 5 then, that tells me how many little squares there are here. How many squares there are altogether is 25. There's my answer. 2 out of 25 does not cancel. 2's will not go into 25. I cannot simplify it down at all. 2's a prime number. So 2 in 25 chances of getting yellow first and then blue second. Okay, not hugely likely, is it? Not hugely likely. Okay, so we're going to see if we can answer these questions. And this is one of those bits where I'm going to pause the video a little bit and let you have a think. Can you answer these 4 questions? So let's just check we understand what the 4 questions mean. The first one says, what is the probability that blue is the first counter? I don't mind what the second counter is. What's the probability that blue is the first counter? And can you give that as simply as possible? Simplify it down as far as possible. Blue is the first counter. Don't mind what I get next. The second question says, what's the probability that both are yellow? Okay. What's the probability I get yellow and then yellow? The third one is a little bit more complicated. What's the probability that both are different? So I need to think that they're not an exact match for each other. Okay, so something like yellow and then red would be good, but I couldn't have yellow and then yellow because then they're both the same. So what's the probability they're both different? And then for the final part, what's the probability that at least one of them is red? So at least one of them is red means I've got a red in there somewhere, but I could have 2 reds. That's okay because that's at least one is red. Okay, so pause the video now. Try and do those 4 questions. When you're happy, you've done those 4 questions, start the video again and we'll have a look at how we got on. Okay, so let's have a look at how we got on then. So I'm going to start with the first question, so that'll be a good place to start. And we're going to have a look at, I'm going to use blue because it's all about blue as my ink on this one. Blue is the first counter. Where do those ones live? Well, this is one, this is one, this is one, this is one, and this is one. They are the only ones. Blue is in the first position. Blue is the first counter. How many are there? Well, if I look at that, how many blues are there? There are 5 of them. Whoops, there are 5 of them. How many did we say there were altogether on the last slide? Well, we said there were 25, didn't we? Because we've got 5 rows of 5. There are 25 boxes here filled in with the outcomes we could get. That's great. If you got that, spot on. Well done. But 5s will go into both. So if we wanted to be absolutely precise about this, we would cancel it down. 5s into 5 goes 1. 5s into 25 goes 5. We can cancel down by 5s. All right, let's have a look. See if I can choose myself a yellow pointer. Yellow bit of ink. Both are yellow. Well, both are yellow. We need yellow and yellow. Yellow and yellow. Yellow and yellow. Yellow and yellow. That's it. Just those 4. I say why. That's all we're going to do. I'm going to change my ink back because we won't be able to see that very clearly. So let's just change my ink back to what I usually use, red. So there are 4 this time out of the 25 in total. 4 out of 25 is my probability. I can't cancel that down at all. The only things that are going to go into 25 that could bring it down at all would be 5, and 5 won't go into 4. So that's done. Both are different. Right, I'm going to move off red because red features in the last one, doesn't it? So let's have a look at, let's try doing these ones in purple then, shall we say? Both are different. So let's start looking across all of these ones. Both are different. Well, red and red, red and red, that's no good. But these 2 are different, and these 2 are different, and these 2 are different, and the next 3 underneath those ones as well. Let's have a look where else. Well, that's different. That's different. These 2 are the same. That's different. That's different. That's different. That's different. 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 Okay, there's quite a lot of these ones, aren't there? Okay, so they're all different. Let's have a look what we've got then. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 out of the 25. Well done if you got all of those ones where they were different. 16 of them out of the 25. And again, we can't do anything with that. The only thing that's going to go into the 25 that's going to help is 5, and it won't go into 16. Right, finally then, we've got at least one red. So if I change my ink colour to red, at least one of them is red. They can both be red, so that's okay. That's okay. That's okay. That's okay. Okay, this is okay. This is okay. Again, these ones directly underneath are okay, aren't they? Same reason. Actually, I missed that one. BR, BR. Red's in there. There's a red in there. No reds in any of those ones. There's a red there. There's a red there. Again, no reds in the next three. There's a red there. There's a red there. No reds in the next three. So what have I got? So I've got all the first row, all the second row. That's 10. And I've got another 6 there, haven't I? So I end up with 16 out of 25 again. These two are exactly the same probability. I've got as much chance of getting both different as I have of getting at least one red.